Your AI agent might be slightly wasting money on every single API call. Not a bug, not the wrong model, just where one line of text sits in your system prompt. I built a fitness coaching agent using LangGraph to prove it. Fixed it in 30 seconds. Cost dropped, responses got faster, and the full code is free on GitHub. Let me show you exactly what's happening. So, what are we building? A fitness coach AI agent called Coach Alex. The agent knows nutrition, training, recovery, everything a personal trainer would know. And it has a tool, Get Nutritional Info, that it can call to look up calorie and protein data for specific foods. This is built with LangGraph. Let me show you the structure. So here, two versions of the same agent, same Coach Alex personality, same tool, same LangGraph structure. One cost significantly more to run. Let me explain why. But first, a quick concept. So, OpenAI has automatic prompt caching, no setup, no config, nothing to turn on. Every time you call the API, OpenAI checks, have I seen the exact prefix before? If yes, those tokens come from cache. Half price, faster response. Just two requirements. One, prompt must be over 1024 tokens. Two, the start of the prompt must be identical on every call. The second one is where most agents slightly break. Let me show you in the code. Here's the broken agent with no cache. Look at how the system prompt is built. Session timestamp injected at the top. Completely normal thing to do. Real apps put user ID, session tokens, current date at the top of the context. But OpenAI caches from the very start of the prompt. That timestamp changes every milliseconds. Now, prefix every single call. New prefix every single call. Cache miss every time. Now look at the agent structure. This is a LangGraph state graph. Inside that React node is the full React loop. Coach Alex reasons about the question, decides whether to call the nutrition tool, observes the result, loop back if needed, then gives the final answer. Every iteration of that loop sends the system prompt to OpenAI. Every single one is a cache miss, full price, because of the timestamp at the top. So you can see cache token 0 every call silently. Now the fixed agent, same file structure, same graph, same tool. Watch what changed. Here the system prompt is 100% static, never changes. If something changes, put it in the end. OpenAI now here, the base prompt, which is Coach Alex's full personality, nutrition knowledge, training guidelines, is the entire system prompt. Nothing prepended, nothing dynamic. OpenAI sees the same 1950 tokens at the start of every call. Cache hit from call 2 onwards. If you need dynamic session data, put in the user message. Like this, yes. And then here the LangGraph structure is identical to the no cache agent, which is a broken agent. Same reasoning, same tool call, same Coach Alex answers. The only difference is that the system prompt line. Inside the React node, you can see the React pattern clearly. This is what makes it agentic, not just one LLM call. Coach Alex actually reasons, decide to look something up, gets the data, then gives you a proper answer. And in a more complex agent, a planner node, a memory node, a response node, every single LLM call benefits from the cache. The savings multiply. Let me show you the real numbers. Run one. I run with the cache endpoint. So here, first time you can see the cache is 0. It's a warm-up. First time it needs to see it. And the second time, the cache, you can see it's 1920 tokens. Cache is hot. We are ready now. So here you can see cached agent, Coach Alex's answer. Look at the response. There is cache token. Now, let's run the full benchmark. 5 runs each. No cache group first and then cached group second. Let's wait. Okay, so here you can see no cache agent, cache token is 0, higher cost per call, cached agent nearly all tokens from cache, meaningfully cheaper, fast responses. Look at the projected monthly saving at scale. That is real money, saved by not putting a timestamp at the top of string. And this is a single node agent. A real production system with 5 or 6 nodes, multiply those savings by your node count. Free code on GitHub, link in the description. Clone it, run it in 10 minutes. The README walks through every step, virtual environment dependencies, API key setup, running the server, hitting the benchmark. The rule is simple. Static content at the loop, Coach Alex's instruction, knowledge, descriptions, and in dynamic content, user ID, sessions, data, timestamp in the user message. Static first, dynamic last. Go check your own agent right now. Look at the cache tokens filled in your API responses. If it's 0, you now know exactly why and how to fix it. Subscribe for more practical AI engineering content. Drop a comment. Is your cache token 0 right now? Free code in the description. See you in the next one.